In this video, I will explain about the formula in finite difference method. And in my previous video, I already explained about the general idea of how this method works. And basically, we are dividing the interval AB into n number of segments. And after that, we need to find the approximation of these y values. And to do so, we need to find the equation of each y value at each interior node. In finite difference method, the linear second order ODE at the interior node is given by this equation here. Actually, this equation comes from the general equation of the linear second order ODE. This equation also can be written as yi double prime plus pi yi prime plus qi yi equals to ri. I value refers to the interior nodes where I equals to 1, 2, 3 until n minus 1. In this illustration here, this is the interior nodes. And this equation, I name it as equation number 1. And then I also have equation number 2, where this is the equation for d squared y over dx squared, the y double prime. This equation is called the central divided difference, and it is used to approximate the value of second derivative. And the next equation is the equation of y prime, the dy over dx. And this is my equation number 3. This equation is called the forward divided difference, and it is used to approximate the value of the first derivative. Okay, next, I can substitute equation number 2 and 3 into equation number 1. And I will get something like this. Okay, this is the y double prime, and this is the y prime. Okay. And then after some algebraic manipulation, you can simplify this equation as 1 minus delta x over 2 pi times with yi minus 1 and minus with 2 minus delta x square qi times with yi plus with 1 plus delta x over 2 pi times with yi plus 1 equals to delta x square times with ri. And this subscript I refers to the interior nodes where I equals to 1, 2, 3 up until n minus 1. And the delta x is the step size or the length for each segment or the length of each subinterval. And the pi value, this pi here, this pi refers to the coefficient of dy over dx, the coefficient of y prime, and qi value refers to the coefficient of y, and the ri value refers to the constant value. By the way, this formula will be given in your final exam, so no need to memorize it. And this formula is used to find the equation at each interior node. Is the equation of y1, y2, y3 up until yn minus 1. before doing that, before you find the equation at each interior node, you can simplify this equation. And how to do that? Just substitute the known values, the value that you can get from the problem statement. For example, this value here, delta x value you can get from the question, or sometimes you need to find the delta x value, just use the formula. And the pi value, qi value, and the ri value always given in the question. So you can get p, q, and r from the differential equations, where p is the coefficient of dy over dx, q is the coefficient of y, and r is the constant value. So after substituting the known values into this equation here, you will get one simplified form of this equation. And after that, you can find the equation at each interior node. So for interior node number 1, where your I is equal to 1, the equation is 1 minus delta x over 2. So as for now, I don't have any value for delta x, so that's why I write delta x as delta x here. So 1 minus delta x pi times with y, I minus 1, so y naught minus 2 minus delta x square q1 times with y1 plus 1 plus delta x over 2 p1 times with y I plus 1, so y2 equals to delta x square 1. And maybe I can write p1 only as p, q1 only as q, and this r1 only r, because p, q, r are the known values. You can get this value from the question, from the problem statement. Okay, and then for interior node number 2, where I value now equals to 2, so our equation is 1 minus delta x over 2 p times with y1 minus 2 minus delta x square q y2 plus 1 plus delta x over 2 p y3 equals to delta x square times r. Then you can repeat this process for each interior node until interior node n minus 1. Okay, so you get one equation. This is the last equation, where interior node now is equals to n minus 1. Okay, and then from this multiple set of linear equations, you can transform these equations into matrix form. And you will get something like this. One matrix for the coefficient of each variables y1, y2, and y3. And this is the second matrix is the y1, y2 up until yn minus 1. And equals to, so this is the constant value of each equation. Okay, and actually, this system of linear equation is called tridiagonal system. And to solve this tri-diagonal system, you can use Thomas algorithm. After solving this system, you will get the y1 value, y2 value, y3 value up until yn minus 1. And these values are actually our solution of our problem now, our ODE problem, the boundary value problem. Next video, I will explain how to solve this tri-diagonal system by using Thomas algorithm. And as for now, I hope you understand how to use the finite difference method in solving boundary value problem of ODE.